Hey everyone, and welcome to today's Explainer. I am absolutely thrilled to have you here. If you're someone who loves to understand exactly how the digital world operates behind the scenes, navigating what we call the intelligence graph, well, you are in the perfect place. Consider this Explainer a masterclass on uncovering, understanding, and honestly, weaponizing public data. We're going to look at exactly how cybersecurity pros and, unfortunately, cybercriminals gather deep intelligence without ever actually hacking into a single private server.
Okay, let's dive right into this by asking a very simple but kind of unsettling question. What is your public data revealing about you right now? Seriously, think about the invisible digital footprint you leave behind every single day. Every forum post, every domain registration, every accidentally exposed company document. To the average person, it's just background noise, but to an intelligence analyst, it's an absolute goldmine.
And that brings us to our core concept today, OSINT, or Open Source Intelligence. Now, IBM defines OSINT as the process of gathering and analyzing publicly available information to assess threats, make decisions, or answer specific questions. What's really fascinating here is the history. This isn't just a modern hacker thing. Going back as far as the Cold War, intelligence agents were doing OSINT just by meticulously monitoring foreign radio broadcasts and local newspapers. Today, obviously, the battlefield has moved online, and it's driving a massive industry that's projected to grow to a staggering $29.19 billion by 2026.
So here is our roadmap for today. We'll start with the OSINT Foundation, move into the Hacker's Playbook, and then master Google Dorking. After that, we'll open up the OSINT toolbelt, dive into social media intelligence, and finally talk about defending your digital footprint. Let's get to it.
All right, kicking things off with Section 1, the OSINT Foundation.
So a comprehensive OSINT process covers a massive scope, and it typically operates on three distinct levels of collection. You have passive, semi-passive, and active collection. The methodology usually moves systematically, starting with basic internet search engines and DNS queries, drilling down through web applications, and eventually correlating that surface data with specialized deep web tools. It's a highly structured, methodical approach to pulling data.
Moving right along to Section 2, the Hacker's Playbook.
You might be wondering, why go through all this effort? Well, it's because of the dual nature of OSINT. On one hand, threat actors weaponize this public data to launch highly targeted attacks. They'll scrape your social media to craft the perfect spear phishing email, or they'll scan public code repositories to exploit known vulnerabilities. But on the other side, enterprise security teams use the exact same public data for proactive defense. They conduct penetration testing, find accidental data leaks before the bad guys do, and assess their own external attack surface. It's literally the same data, just used with a completely different objective.
And to put the sheer scale of this threat into perspective, it is massive. Platforms like BitSite monitor over 1 billion compromised credentials added from the deep and dark web every single week. 1 billion. Threat actors are relentlessly harvesting this data, which means defenders have to be just as relentless in their own intelligence gathering.
Okay, let's get into Section 3, Mastering Google Dorking.
And we're talking about a technique called Google Dorking, which is sometimes called Google hacking. Imperva defines this as utilizing advanced search operators to uncover specific information not readily available through standard queries. Think of it like a digital magnifying glass. Because Google indexes practically everything its crawlers touch, analysts can actually exploit those indexing algorithms to find hidden files, exposed servers, and sensitive directories. This allows for what we call pivoting, taking one tiny piece of discovered data, like an exposed username, and using it to systematically unravel a much larger interconnected network of info.
So standard searches just look for keywords, right? But if you type site:/nytms.com, you are forcing Google to only look inside that specific domain. Or try adding filetype:/PDF to your search. Suddenly, you aren't just finding web pages anymore. You are finding actual documents. If you combine these, say site, company.com, filetype, PDF, password, you might just uncover a highly sensitive internal corporate document sitting right out in the open. Operators like inURL and intitle narrow that scope even further, letting you pinpoint exactly what you need. It's wildly powerful.
Which brings us to Section 4, the OSINT Toolbelt.
Manual searches are great, but eventually you're going to need scale. Here are the heavy hitters used by professional analysts. If you don't know where to start, OSINTframework.com is basically this massive, interactive directory tree of free tools for almost any query you can think of. Then there's Maltego, which is amazing for visually mapping data connections, showing you exactly how an email links to a domain, which links to a server. Shodan acts like a search engine for the Internet of Things, literally finding open ports on webcams, routers, and servers worldwide. And frameworks like SpiderFoot and Metasploit allow security teams to automate the discovery of these public vulnerabilities across massive networks.
Next up, Section 5, Social Media Intelligence, or SOCMINT.
SOCMINT generally targets three main categories of data: profile info, interactions, and metadata. And the scale here is just staggering. Consider this: over 350 million images are uploaded to Facebook alone every single day. Analysts use specialized tools to make sense of this massive influx. OSINT pulls metadata directly from Instagram, while tools like PictureScan handle deep image analysis. Crosslinked is used to collect employee names from LinkedIn through search engine scraping, and FABot will alert you the literal second a specific keyword is mentioned on Reddit. It's all about turning social noise into structured, actionable data.
So the crucial takeaway here is this. While OSINT gives you incredible visibility, it's really just the foundation. To get a complete threat profile, security teams often have to take this surface web data and correlate it with deep and dark web intelligence monitored across networks like Tor and I2P. Think about it. An exposed email found on LinkedIn only becomes a critical threat when it's correlated with a password dump found on a Tor hidden service.
Finally, let's wrap up with Section 6, Defending Your Digital Footprint.
How do we protect against everything we just talked about? Well, here is a step-by-step mitigation guide based on best practices from Imperva. Step 1 is the most obvious: strictly restrict the information you share online. But practically speaking, Step 2 is vital. Implement a properly configured robots.txt file. This file literally tells Google's crawlers what they are not allowed to index, and it acts as a direct shield against Google Dorking. Combine that with NoIndex tags on your sensitive pages, conduct regular audits of what you're actually exposing, and rigorously limit your server directory permissions.
Beyond just the technical configuration of your website, you absolutely have to safeguard PII, personally identifying information. Not only do threat actors use this stuff to bypass security questions and craft phishing attacks, but failing to protect it puts your organization in direct violation of strict compliance frameworks like GDPR. You need to continuously monitor the dark web to ensure your vendors or employees haven't had their protected data compromised. That is how you stay one step ahead of data brokers and threat actors.
Which leaves us with a final, provocative thought to end today's explainer. After seeing these tools, the sheer scale of data collection, and how simply Google search operators can uncover hidden files, do you truly know what your digital footprint looks like today? I challenge you to apply the mindset we talked about today, take a hard look at your own external attack surface, and see what you can find. Thank you so much for joining me, and keep learning.